So we know we want to look at linear relationships, and we know we want a way to gauge the strength of those relationships and also whether they're positive or negative. But we realize that just making guesses for moderate versus strong or weak versus moderate is no good for us. We need a number that will measure the strength. And that's what the correlation coefficient does. The correlation coefficient is abbreviated by the little letter r, lowercase letter r. It's a numerical measure of strength and direction of the linear relationship between two quantitative variables. Now the formula is right here, but we're not actually going to calculate this by hand, so I'm not particularly interested. If you look, you can see it's actually z-score formulas. You take the z with respect to the x direction, multiply it by the z with respect to the y direction, then you add them all up and you divide by n minus 1, in case you're interested. But we are never going to find this by hand. We're just going to use the linear regression function on our TI-84 calculator to do this, and we'll get instructions on that later. So we'll never find it by hand, for starters. We're going to use linreg, linear regression, to find it. It is not resistant to outliers for various reasons. Primarily because it's built off of the mean and the z-scores. So if you see there's an x bar and a y bar in that formula, those are means, and the means are not resistant to the outliers, so neither would r be. So not a big deal. It doesn't have any units, so it doesn't have feet or inches or degrees or any of that stuff. So it has no units. That's one of the few items that we have in this class that don't have units. Another big one being z-scores. So z-score and r values don't have units. And that's of course because if you look at the formula for the thing, it's built from z-scores. That's a z-score in the x and a z-score in the y. See how it's x minus x bar over s? That's a z-score. So it's essentially a glorified z-score calculation, which means it's not going to have any units, right? We usually round r to about 3 to 4 decimal places, mostly. There can be exceptions to that, but mostly 3 to 4. And then this is just a real quick caveat. R alone is not a guarantee of a linear relationship. It can kind of give you a guess of whether there's a linear relationship, but if you know the relationship is linear, then R can tell you how strong it is. But just having a high R value, a strong R value, does not necessarily mean it's linear. Well, to do that, you would actually need chapter 14, which is when you're doing hypothesis tests on linear regression, which we won't actually cover in this particular course, but you would do in like a Stats 2 course. So just suffice it to say that a high R alone is not enough. You need a graph and a high R, or a graph, a high R, and some other stuff that we're not getting into, which is chapter 14. So we'll talk about this a little bit more in section 4.3, but just be aware that R alone does not tell you it'll give you a measure of strength if you know it's linear, but if it's not linear, R can't make it linear. All right. Now, what the heck am I talking about? Well, there are some things to know about R. First of all is that it has a sign. So it's going to be either positive or negative, right? Positive values will mean that there was a direct relationship. Namely, as x increased, y increased, which means you can see the graph, right? It goes up, generally, trending upward as you move from left to right. A negative R means you have an inverse relation. It means that as x increases, as you move to the right on the graph, the y decreases. All right, so that the sign will give you direction. Now the absolute value describes the strength. So R is always going to be between -1 and 1. Because that's a fallout of the fact that it's a giant fraction. So it can never be higher than 1, can never be lower than -1. So the greater the absolute value of R, in other words, the closer it is to 1 or -1, the better, which is what this says. Strong relationships have R values close to 1 and -1. Weak relationships have values that are close to 0. Now, and again, just to reiterate, R only measures linear relationships. R cannot tell you whether it's linear or not, but it will tell you the strength of a linear relationship if it's known to be a linear relationship. All right, so then I've color-coded everything for you here. So the purple is perfect negative or perfect positive. So the negatives are on the left side, and the positives are on the right side. So perfect positive is just the dot at 1, perfect negative is just the dot at -1, that's it. Strong relationships are between negative zero point 0.8 and -1. So this green zone right here, from negative zero point 0.8 out to -1, but not including -1 because -1 itself is a perfect relationship. And strong positive on the other side is from zero point 0.8 to 0.1. Again, not including, or 0.8 to 1, not including 1 itself because 1 itself is a perfect relationship. All right, then a moderate relationship is the blue zone. So moderate negative over here on the left goes to negative 0.5, right? It includes negative 0.5, so that's why there's a dot there. Moderate positive is from 0.5 up to 0.8, not including 0.8. 0.8 is strong, but 0.799999 would be in the blue zone. Then you have your weak relationships, which are these orange zones here. So you got your weak negative here on the left, your weak positive here on the right. And then in the middle, you have your no relationships. I mean, it's just so terrible to be between negative 0.3 and positive 0.3. So you could write this down in a table on your note sheet, or you could draw this graph, or both. But one of these two things should definitely go on your exam note sheet. This is the kind of stuff you desperately need for your exam notes. You don't have to memorize it. You just have to be able to use it. Speaking of which, let's use it. So we have a bunch of R values right here. And our mission is to figure out which of these graphs matches those R values. Okay, well, we'll start off with the easiest one, the 1 and the -1. The 1 and the -1 are perfect relationships. So we are going to see those on the graphs as perfect. So it looks more like what an algebra graph looks like. Everything's in a lockstep. All the ducks are in a row. So for letter C and letter H, those are perfect relationships. Because C is positive, that would be a positive 1 for C, and because H is a negative relationship, that would be -1 for H. Next, I'm going to look at my strong zone ones, which are the 0.83, which is in the strong positive side, and the negative 0.95, which is quite frankly very strong. Being in the 0.90s is often in some books referred to as very strong. So it should be that the dots really follow that line carefully. Sorry, not trying to make you sick. So we want to look at the graphs, and when I look at all of them in a row, I can see that the strongest graph, other than the perfect ones, which are the best, but the strongest graph besides that is letter B. To see how it's negative, but those dots are really close to that line. That would be R equals negative 0.95 for sure. Right? It's quite strong, very strong in fact. By the same token, when I look at the positive ones, the strongest one out there is actually this one on the top left corner. The other two are both positive. E and G are both positive, but they're a bit weaker. So this is accurate. This is actually what about 0.83 looks like, which is strong. I mean, you can really clearly see the trend line in there. Right, so those dots are really clustering around that trend line. Even if the line was missing, you could see that relationship. So that is strong positive right there in the top left corner. Okay, well, let's deal with the terrible ones next. So negative or positive 0.11 and negative 0.22 are both in the danger zone. Or if you want to be like the cartoon character Archer, the danger zone, right? So they are in a bad place. They're going to be a very weak, no linear relationship thing. All right, so, but one of them's worse than the other. The positive one is even worse than the negative one. So if I look at our relationships here, so we have letter D, we have letter F, E, G. Well, G is positive and terrible. So G is rather obviously the positive 0.11. If you didn't have that line drawn for you by the computer, you would never in your wildest dreams think that that had any kind of relationship because it's just so terrible. So that is 0.11. It is very weak. Basically no relationship whatsoever. All right, now that leads to the negative side. Which one is the negative 0.22? Well, it's obviously not letter B. It can't be E because E is positive. So that leads us to D and F. Well, we're going to make a little bit of a judgment call here because we don't have the points given to us. So kind of envision for yourself for just a moment, what if the line was missing? So if the line is missing on letter D, you can still see the downward trend, right? It starts up, a little, you can kind of see the banner moving its way left to right, and it kind of moves downward. If the line is missing an F, you would kind of not even know that that's necessarily negative. That's got this big cluster over here, and then it looks sort of like a flag. I mean, it sort of looks like a rectangle. That's not good. When your data set looks like a rectangle, that kind of shows no relationship. Like you're not really seeing a good negative linear relationship on that one. So this is actually the one that is negative 0.22, which by default means that this one, letter D, must have been negative 0.44. And that's how we do these problems. Sometimes you kind of have to work your way around the ones that you know to figure out the ones that you don't. Now, negative 0.44 is weak. I'm not saying that it's a strong relationship, but it's certainly not as bad as letter F. Letter F is really not good. So this is a weak relationship for letter D. And then for letter E, that's the last number left, that must be the 0.59. So the negative 0.44 was weak. And then the 0.59, that's actually a moderate relationship. And a moderate relationship looks like letter E right here. And just to make things clear, I went back and labeled everything for us. So A was strong positive, B is a strong negative, C was perfect positive, D was a weak negative, right? And that's basically what it looks like. So there's a little bit of a trend there, but it's hard to see. E was moderate positive, so not bad. It's got quite a significant trend. You can see the relationship even with the line was missing. F and G are both no relation. They're just blobs of points, right? So rectangles are blobs of points that have no really good relationship at all. And H is a perfect negative relationship.